Hi students, my name is Otin Joseph. Welcome once again to the OK Academy e-learning program. I'm your facilitator for grade 5 mathematics. We are going to have a lesson in mathematics on the Eratosthenes method. How to use the sieve of Eratosthenes. Please, when you are mentioning it, take your time, or you might be saying Eratosthenes, which is not right. Eratosthenes. We are going to use the sieve of Eratosthenes to find prime numbers between any given set of two numbers. Any given set of two numbers. So let's go to the board. Let's say we have been given the numbers 10 and 50. And the question says, use the sieve of Eratosthenes to find the set of prime numbers between 10 and 50. Or the question might not ask you to do that. The question might just say, find the set of prime numbers between 10 and 50. You can just apply the sieve of Eratosthenes to make your work very simpler and easier. So, how do we apply the sieve of Eratosthenes? It is very, very simple. You have to draw a box first, a big one, of course. So I'm going to draw my box on the board. The next thing to do is to divide your box according to this. You are going to take the difference between the biggest number and the smallest number. I have 50 and 10. So the difference between 50 and 10 is 40. I'm going to divide my big box into 40 smaller boxes, okay? So I will start numbering from the smallest number to the largest one. This one I start from 10. So 10, 11, 12, like that, till I reach 50. The next thing to do is to draw a big box and number from the starting number to the last number. So I will number from 10 to 50, so I need a big box, of course, divided into smaller boxes. Now I have divided into smaller boxes and I have counted from 10 to 50. After doing this, the next thing you have to do is to start from the first number, which is 10. Look at it and ask yourself, is it a prime number by finding its factors? 10 is not a prime number. If the number is not a prime number, what you do is you circle it. So any number you circle in the box is not a prime number. Then you come to the next number, which is 11. Is 11 a prime number? Yes, it has only two factors, 1 and 11. So you cancel it. Any number you cancel inside the big box is a prime number. I move on to 12. Is 12 a prime number? No. 12 has many factors, therefore I circle it. What about 13? Yes, it has only two factors, 1 and itself, so I circle it. So what about 21? How many factors does 21 have? 21 has about 4 factors, therefore it is not a prime number. So I circle it. What about 22? 22 has factors 1, 2, 11, and 22, 4, right? A prime factor is supposed to have only 2 factors, 1 and itself. So I circle 22, it isn't a prime number. What about 23? 23 has only 2 factors, 1 and 23, so it's a prime number. I cancel it, right? 24, 2 can divide 24 so that I get 12. 3 can divide 24 so that I get 6, right? So therefore 24 isn't a prime number. I circle it. 25 has the factors 1, 5, and 25 itself. 3 is not a prime number. I circle it. 26 has the factors 1, 2, 13, and 26, 4. Therefore, it isn't prime. 27 has the factors 1, 3, 9, and 27. It isn't a prime number, okay? Because it has 4 factors. 28 is not a prime number, okay? So I circle it. 29 has only 2 factors, 1 and 29. Only 2, 1 and itself. Therefore, 29 is a prime number. What I do here is I cancel it. 30 isn't a prime number. It has a lot of factors. So I circle it. But check out some of the factors of 30, okay? It's your assignment. 31 has only 2 factors, 1 and 31. Therefore, 31 is a prime number. I have to cancel it. Let's come to 32. 32 isn't a prime number because it has more factors. It has 2, has 16, it has 4, a lot of factors. Name them. So I circle it. 33 has the factors 1, 3, 11, and 33. 4. Therefore, it cannot be a prime. So I circle it. 34 isn't a prime. It has a lot of factors. What about 35? It's not a prime. 5 is there, 7 is there, 1 is there, 35 is there. It can never be a prime. So what I do is I circle it. Okay? Don't worry, we are circling a lot of numbers because the set of prime numbers really doesn't have a lot of numbers. Now 36. 36 has 6 as a factor, 1 as a factor, and itself. Therefore, it's not a prime. So 36 has the factors 6, 36, 1. A lot of factors, okay? It's not a prime number. What about 37? 37 has only 2 factors, 1 and 37. Therefore, 37 is a prime number. So I cancel it. Okay, we cancel prime numbers and we circle numbers that are not prime. 38 has more than 2 factors, so it is not a prime number. We circle it. 39 has more than 2 factors. Count 3, 13. Therefore, I circle it. What about 40? 40 has more than 2 factors. It's not a prime. What about 41? 41 has only 2 factors, 1 and 41, okay? So I cancel it. 42 has more than 2 factors. 2 is there, 12 is there. A lot of factors, so I circle it. 43 has only 2 factors, 1 and 43, okay? So what I do is I cancel it. 44 has more than 2 factors. Therefore, I circle it. 45 has 7 as a factor, 5 as a factor. It can never be a prime number. 46 is not a prime number, okay? It has more than 2 factors. So I circle it. 47 has only 2 factors. What are they? 1 and 47, okay? Any number with only 2 factors, 1 and itself is a prime number. So this is going to be a prime number. I cancel it. 48 is not a prime number. It has a lot of factors. So I circle it. We know that 7 times 7 is 49, right? 1 is there, 49 is there. 49 has a lot of factors. So it is not a prime number. I circle it. What about 50, the last number? It has 5 as a factor, it has 1 as a factor, it has 10 as a factor, 25 as a factor, a lot of factors, name them. So it can never be counted as a prime number. I circle it. So we are done. So we have some numbers circled, whilst others have been cancelled. Which ones are the prime? If you remember, the numbers that I would be cancelling are those that count as prime numbers. Therefore, so any number that has been cancelled in the box is a prime number. To prove this, or to show this, or to distinguish the prime numbers from the non-prime numbers, I have to create a set for them. So therefore, so I create my set starting from the first number that was cancelled inside the box is 11. I write it. 13 was also cancelled. So the next one is 17. In fact, when you are doing this, you have to take your time and do it gradually, okay, so you don't make mistake. Mixing numbers that are not prime with those that are prime, okay? The next one is 19. The next one, 23. The next one is 29, then we come to 31, followed by 37 and 41. Finally, we have 43 and 47 closing the set. Okay, so now I have my set of prime numbers. This is a set of prime numbers. This is called the sieve of Eratosthenes. What do we mean by a sieve? A sieve is used to what? Sieve something. Take some things from other things, right? When you have a mixture of things, you sieve some things out. So this is a sieve. We have cancelled prime numbers. We have circled non-prime numbers. That makes this the sieve of Eratosthenes. You see how easier and faster it is to use this method to find a set of prime numbers between any two given sets. Okay, I'm giving you this set of numbers to try whilst at the comfort of your home. So what you have on the board is the one you have at your disposal to try at home. Try this one at home, okay? Try using the sieve of Eratosthenes to find a set of prime numbers between the following numbers: 1 and 40, and then 5 and 60. Whilst you are enjoying your corona lockdown in the home, try this. Make sure you understand the sieve of Eratosthenes very well, because that is what you are going to use for the assignment that have been given to you. Okay? Make sure you come to the school premises to pick your assignment, do them judiciously, and submit them for marking and grading. My name is Otin Joseph. Once again, I'm your facilitator for grade 5 mathematics. Stay home, stay cool, take good care of yourself until we meet another time. Bye-bye.